Here we are at the warm-up for our 2.1 notes. We're asked to find the slopes passing through each of the following points, and here's that equation, y equals x squared plus 1. As we can see, we have different graphs, and we actually have different x values. So for example, we see that this first one is 1, 2, and here is that point. And then we also have 3, 10 right here. So essentially what we're finding here is the slope between these 2 points, which happens to be then the secant between these 2 points and this graph. So if we're just looking for that slope, we know from algebra that it just comes out to be y2 minus y1. We'll just label these first. So y2 minus y1, so 10 minus 2, over our x2 minus x1, so 3 minus 1. So simplifying that, looks like we end up with 8 over 2. And so it looks like this slope for this secant line comes out to be 4. Now looking at the second one, we notice that we still have the point 1, 2. And our point is actually getting a little bit closer to 1, 2. Now it's at 2, 5. So for the slope of our secant here, we'll call this one x1, y1 again. This one x2, y2. Again, follows the exact same setup. We have 5 minus 2 over 2 minus 1. So then it looks like this slope comes out to be 3 over 1, which again would just be 3. So for our slope for the secant of that line, comes out to be just 3. Now we have a point that's much, much closer to, essentially we'll call this 1, 2 our target point. So we'll say he is our target point for now. But again, he is the x1, y1, just like the others. And we'll call this one x2, y2. But you can tell that we're getting closer to this target point of 1, 2. Well, let's go ahead and find the slope then of this. So again, we are still finding a secant slope between these 2 points. It's just really, really small. But we end up with 2.1025 minus 1. Oops. We actually have minus 2 all over our x2, 1.05. minus our x1, 1. Simplifying this up, looks like we just end up then with 0.1025 on top over 0.05. And when we throw that in the calculator, we end up with 2.05. So our slope between this secant line comes out to be 2.05. Now if we were to go ahead and zoom in closer, because right here it's pretty hard to see kind of like what's going on, but you can kind of make out 2 different points. But let's go ahead and just zoom in a little bit more. And there they can clearly be seen where we have 2 different points. And pretty much what we're trying to illustrate here is that what happens when you get infinitely closer to that 1, 2 target point. Again, this 1, 2 was our target point that we were hoping for. And we kept seeing that from our warm-up, we kept getting closer, closer, and closer, and closer to that target point. Well, as a result, we noticed that looking at those secant slopes, that for right now they're going down, but they don't always have to go down, but they are getting hopefully closer to the true target point slope. And that's mainly the idea that we're trying to walk away with here. So we get closer to the true slope of our target point. And from geometry, the secant lines were what we were actually calculating. The slopes of those were the secant lines. And our hope is that eventually you can get so close to that target point that it becomes the tangent line to our particular point, or at our particular point. And again, that's actually back from geometry where we talked about secant and tangents. Secant is just 2 points, much like this, and you're pretty much finding the equation based on those 2 points. And the tangent is where it only touches it once. So kind of like this, but it's only touching the line once. That's what a tangent is. But again, though, that is the warm-up from our 2.1 set of notes, just looking at secants and converting them into a tangent slope.